Okay, stats. This is part B of section 9.2. On the front side here, we did the testing for two means, so we were comparing two means. So we compared females and male professors, and we found that their averages were about the same as each other. So we did a fail to reject, claim was valid. They're going to have us test the same thing on the other side, except this time we're using the confidence interval method. Okay, so we should end up with the same conclusion as what we did on the front side. I went ahead and copied down the information here from the front side, so our averages, our standard deviations, the number of data points that we had for each sample. So if you want to go ahead and copy those down, we have those here. Females we designated to be the number ones, males we designated to be the number twos, just because that's how it showed up in the table. So that's X1 bar is the average for females, X2 bar was the average for males, that type of thing. So really our average is what we got here. We're comparing like 3.867 and 3.993. So even though the males were ever so slightly bigger than the females, so the average for the males, they scored higher than the females, but they're saying those are pretty well close enough to being the same number that we can't definitively say that males was significantly higher than females. Okay, so that's kind of what we were doing on the front side. So confidence interval method, this is what we're trying to do. We're trying to set up this confidence interval. We've got those three pieces, and then we've got this less 2 in the middle. Okay, mu1 minus mu2 we say is 0, because if we're trying to say that mu1 equals mu2, we would subtract that mu2 to the other side, and we would get mu1 minus mu2 equals 0. Okay, these two things, this thing right here and this thing right here, mean the same thing. So we'll put 0 in the middle here, and then we just check these two numbers, and we try to see what our confidence interval is. Okay, so we need to calculate the error, and this is the formula for our error based upon this information down here. Okay, so let's do that first. Again, we're doing a 95% confidence interval. Okay, so our error is, we need to know what that t of alpha over 2 is. That's one more thing that we need. So I need to know that number. So I'm going to leave a blank for him, and then I'm going to do the square root of all that other junk. Okay, so I need my standard deviation, which is 0.563 squared. That's my first standard deviation, over 12. My second standard deviation, 0.395 squared, all over 15. Okay, and then I need that t of alpha over 2. Okay, so again, we're on our t chart, and it says that for that t of alpha over 2, we use the smaller of the n1 minus 1 or n2 minus 1. Okay, so we're looking at degrees of freedom there, right? So degrees of freedom, if I'm looking at 12, is 11. Degrees of freedom, if I'm looking at 15, is 14. Okay, I always subtract 1, and the smaller of those two is 11. Okay, so if we go back to our t chart, this is going to be the same t as what we used on the front side. I'm going 11, and I want to do 95%, which is what we did on the front side. So 2.201, that number is the same. 2.201 is the number that I want to use for my error. Okay, so let's type this in and let's see what we get for error. All right, I'm going to, let's see, 2.201 times, and then we want the square root of all of this stuff. Okay, and I'm not going to open up any more parentheses than I need. It should, by order of operations, go ahead and do this divided by 12 plus the 0.395 squared divided by 15, and then I'm going to close my parentheses. Okay, and that gives me, my error is 0.422. Let's see, we'll go 3 decimals there again. Okay, one thing that I have people get mixed up when they're doing error or even the formula on the front is to calculate degrees of freedom, we subtract 1 from this number, we subtract 1 from this number. But when they go to do the formula, they want to use 11 and 14 instead of using 12 and 15. Make sure that you're still using 12 and 15, because that is what n is. It's not n minus 1 in the formula. It's just n. Okay, so don't use the subtracted 1 in here. Okay, so we have our error. All right, now we just need to write our confidence interval out. So we have x1 bar minus x2 bar minus the error, and then x1 bar minus x2 bar plus the error. Okay, that's where these two things come into play, because we haven't used them yet. Okay, so I'm going to write this all out. I'm going to subtract my error, is less than 0, because that 0 lives in the middle, is less than this guy plus my error, 0.422. Okay, and my x1 minus x2, I take that 3.867 minus 3.993 and 3.867 minus 3.993. So I'm adding error and subtracting the error on either side. Okay, and then I'm going to get an answer, and I'm going to see if 0 lives in between those two. Okay, all right. So let's see, 3.867 minus 3.993 minus 0.422. Okay, is a negative 0.548. Okay, and then I'm going to go back up into my equation, and I'm just going to add the 0.422 instead of subtracting. And this guy is 0.296. Okay, so this is our confidence interval. That's our final answer, and then we just need to make a conclusion from that. Okay, so I'm gonna bring my null hypothesis over from the other side. My null hypothesis was that the averages for the females was equal to the average for the male. Okay, my alternative hypothesis was that the averages were different. Okay, so even though the averages technically are different, right? 3.867 is different from 3.993. Okay, they're saying, are they different enough to say that they are significantly different, right? Or was it just kind of a fluke this time that the guys got a higher score than the girls? Okay, well, they are saying, since 0 does in fact live in between these two, we are going to fail to reject this guy. Okay, if 0 didn't live in between there, we would say that this was not true, but right now we're going to fail to reject, just like the front side, fail to reject null hypothesis. The claim went with the null hypothesis, so the claim is valid, which means that males and females are the same average or mean. They have the same mean value or the same mean score. Okay, so same as what we did on the front side, just a different way. And there you go. On your homework assignment, I think I put this in a note from yesterday, but I want you to do number 1. So just talk about whether they're independent or dependent. Okay, and then you can skip number 2, go do number 3. You should have been able to do yesterday part A, but now add part B to that. So 3A, part A, part B. Part B is the confidence interval method, and then do number 5, A and B. So you should have been able to do 5A yesterday. Now 5B will add to that, construct a confidence interval. Okay, so just the odds basically on this page. 1, 3, 5, both parts A and B on 3 and 5. Okay, and I will not make you do the evens. So there you go.